All right, let me just go back to this. Okay, here. No, wait. Okay, so this is just some kind of strategy that the book has. I thought it wouldn't hurt to present it here as well. This is what you can use when you're solving their word problems. The first statement's kind of a duh. It's, you read the problem carefully. Wait, let me make sure I'm recording. Oh, yeah, I am. Good. The first one is read the problem. You want to understand, of course, what's going on. And you want to be able to identify any change in quantities, because those are going to be the variables, like time, cost of something, things like that. You'll see where we do problems. And of course, you want to choose variables to represent those. And what you're also going to want to do is you're going to also want to look for information, while you're reading, for any important values of the variables. I mean, you'll see where we do some examples. You might have something like the person starts out with a certain amount of money, and every week they're spending this amount. The problem is going to give you some kind of clues to figure out, like what the rate of change is and, what kind of function you're dealing with, that kind of thing. And of course, and number 3, basically, you want to figure out a way to solve the problem. You might have to come up with a formula for a function. You might have to do some calculations, like that. Then, of course, you solve the problem. It's good to also reflect to see if your problem if the answer you got, makes sense. For instance, if you're looking for a problem, if you're trying to solve a problem where, how long will it take someone to save enough money for this, and you say like -50 years, that's not going to make sense, right? So you want to make sure your answer mathematically is right and makes sense in the context of the problem. And step 6 is you just want to make sure you use the right units, that kind of stuff. You don't have to memorize this strategy. It's in the textbook and it's in my notes, of course. So I'm not gonna, if I were to ask you, for the steps or whatever, I would give you the steps on a quiz or something, or test. You don't have to memorize the steps, in other words. I mean, if you can, you're ahead of me, because I can't. So what I'm going to do is the first problem. This came from the textbook, so I don't remember if anyone in the class's name has this name, but that's just coincidence. But this is the problem from the textbook. So this person, Ariel, is saving up money, and she saved up $3,500 for a trip to Seattle. And of course, this should not be appending. This should be spending. I spelled this wrong. That's my fault. So here, let me see if I can fix that quickly. Misspelling on my part. Should be spending. Sorry about that. So spending, she's going to spend about $400 a week, she anticipates. And that's going to be on rent, food, and all the other stuff. So the question they want to know is, how long can she afford to be in Seattle? Okay, right away, there are 2 changing quantities, right? I mean, one of them is, of course, going to be time. She's staying there not just for a day. She's staying there for, we want to know how long she's going to stay there for. But money is also changing, right? She's spending money. Every week we're given she's going to spend $400. So every week she's going to lose $400 from how much she saved. Okay, so because those are the changing quantities, those are our variables. Okay, I wrote that twice. Why did I write that twice? I guess for emphasis. So, but what we're going to do is we're going to let M be, how much money she has left over in dollars. And her okay, so that's also going to be our output. And time, in this case, we're going to have weeks. That's going to be our input. If she wants to stay this long, how much money does she need? That kind of thing. So this is our first variable, how much money she has. Here, time is the other variable. Okay. Now notice also, notice also, we can really determine, we want to know how long she can stay till, but she can only stay until she runs out of money, right? I mean, once she's out of money, she can't do anything else, then she has to leave. So we want to know when she runs out of money. Now, in terms of our notation, what does that mean? Well, that means we want to know when M is 0. We want to know when M is 0. And how long does that take for it to happen? You know, we read the problem, right? We're looking for important information. That's what we're kind of doing. You know, she's spending a certain amount, $400 a week, and she has this amount, $3,500. Okay. So we read the problem. Those are important information for us. And notice there is a rate of change here, right? She's spending $400 per week. So what does that tell us? That tells us M, how much money she has, that's decreasing at a rate of $400 per week. Remember also the rate of change, the units for it is the output divided by the input. So our rate of change here would be negative 400. Okay, the rate of change here. Okay, so we have important information, but now how are we going to solve the problem? We want to know how long she can stay till. We want to know when M is 0. Well, here's a plan of attack. Let's see if we can get M in terms of X. We have that. Let's see if we can get M in terms of X. Well, we know the rate of change, right? Since the amount of money is decreasing, that's why it's negative. And she's starting out with 3,500, right? So that's our initial value. So this would be our M. Okay, again, we have a linear function. The rate of change, that's how much M is decreasing by, right? For each unit increase in X. So for each week, she's losing 400. This is the starting value. We want to know when she runs out of money. We want to know when M is 0, right? So that's our plan of attack. Well, how are we going to do that, though? I mean, we could, I guess, do some calculations by hand, but since we have our function, we can just solve it algebraically. Okay, and that's what I'm doing here. So, you know, it's just basically an algebra problem, right? We're solving for X so that this is 0, and through some calculations, we end up getting this. So in about 8.75 weeks, remember X was in weeks, right? That was our unit of time. She'll run out of money. Now, does that make sense in the context of the problem? Well, based on what we have, yes. I mean, there are, I guess, other things we could consider. Because if she's staying somewhere where, I don't know, like in a summer housing unit or whatever, but they charge by the week, right? Then she can stay past the 8th week because she can't afford another week after that. But again, we're not given that. So really, for the context of the problem, this is right. You know, our calculation is right. You know, this makes sense in the context of the problem. So, you know, that kind of stuff. Okay. All right. I mean, if the unit she's staying in charges by the day, then yeah, this is the right answer. So, okay. Now, we didn't do it here, but we could have probably done some calculations to really help us see what's going on. So, for instance, after week 1, she would have $3,500 minus $400. And what would that be? I guess 20, that'd be 3,100. And then after another week, we would subtract another 400. You could do calculations like that to help understand what's happening. We didn't do that here, but in the next problem we will do that. First, before I get to that, hope that makes sense.